And whiteboard. And my cat's been messing with my, there we go. All right, so just to go over, to help you remember what we did yesterday, let's go ahead and do this one. This is kind of attached yesterday with today. You got one that's bordered by the x-axis, the y-axis, which means y is equal to 0 and x is equal to 0. Sometimes they might do it like this and put bordered by. Sometimes they may do it like this. X is equal to 4 and y is equal to the square root of x, and you're rotating it around the x-axis. All right, I'm going to give you 3 minutes to get this one started. Of course, the first thing you're going to do is draw it, sketch it. So 3 minutes in the handy-dandy timer, and go. You should be able to get at least halfway to 3/4 way through it. If you can't, then we'll just chalk it up as being a failure in life. Right, Mr. Adamson, it's always good to be a leader, right? Be a failure in life, that's a leader. First failure in your family, that's a leader. Mr. Vienna, thank you for showing us your face this morning. It's better than a light. Thank you. Miss Hull, nice wall or ceiling, or Mr. Hull, nice wall or ceiling. Thank you for the wall or ceiling. 3 ceilings today. We're at least cutting down on the ceilings. Although we still have one person that haven't turned their video on, but I'm not going to bitch about it. I'm not going to beg you. You don't want to communicate with the class, that's fine. All right, there's 55 seconds left. And we may have done one like this yesterday, but I'm doing it, just to, refresh your memory, because all but 5 of you haven't touched your homework. There's only 5 of you that have touched your homework. So the rest of y'all haven't done a damn thing. So I figure it would help to at least, do this for memory, for those people that haven't done anything. So x is equal to, we'll color that pink. That's this guy, Let's see, that's the x-axis. That's this guy, sorry. And we'll color this one yellow. And that's the y-axis. X is equal to 4. And, oh, I forgot to color that blue. And we'll color this orange. Nice to know those parent graphs that I told you to write down at the beginning of the semester. That algebra stuff. So they want to find the volume of the green area because it's rotated around the x-axis. So that means we got a hairline and it is going around and it's basically causing a disk. So that's going to be volume is equal to from 0 to 4 of, don't forget pi, of x to the 1/2 raised to the 2nd power dx. And then that's going to be v is equal to pi 0 to 4 of x dx, x squared divided by 2 evaluated at 0 and 4 multiplied by pi. And of course we got the same thing we got yesterday, 16 over 2 pi, which is 8 pi. Now, I really could care less about the math. I just want to make sure you can get to the setup. Okay, and that is 6.2? 6.2? 6.2. Or 6.2 difference, yeah. 6.2 is difference between two curves, isn't it? I think it is. And 6.3 is disc and shelves, I think. And disc and washers. And then I think shell is 6.4. So that's what I showed you yesterday or the day before. I can't remember. And that's kind of a review over that for those people that did not do any homework in the last couple of days. Okay. Yeah, I'm going to keep saying that because you're not doing your homework like you're supposed to. And don't whine when I put an end date on it. And don't give me the 5 dead grandmothers and your dog's been in the hospital and the 4 flat tires on your car, all that bull crap. Because that's what I'm sorry. I don't know whether to believe you or not. All right, next question. I'm going to give you the question and then I want you to draw it. And this is new material, so you should at least be able to draw it. Y is equal to x. Y is equal to x cubed. And all this is going to be in the first quadrant, so x is greater than or equal to 0. So go ahead and draw that for me. Give you a minute or two to draw that. And go ahead and find where they intersect. So x is equal to x cubed. Go ahead and find out where they intersect. give you 2 minutes to do those two things. Now you're wondering why I'm timing you? Well, you need to be able to do these problems in about less than 4 or 5 minutes. If you're spending 10, 15 minutes, that's unacceptable. Okay, that's what the graph looks like. This is x, and this is x cubed. So they want to know the volume of this guy. And I forgot to tell you, it's around the x-axis. Around the x-axis. Okay, so x, so that's going to be 0 is equal to x cubed minus x. 0 is equal to x times x squared minus 1. 0 is equal to x. 0 is equal to x squared minus 1. X is 0, positive or negative 1. And we don't care about the negative 1, so because of that. So ours is 0 and 1. So we're revolving around the x-axis. So what does that form? What is a disc with a hole in it?
A washer.
It's not a donut. It's a washer. Okay? So how, somebody tell me, just looking at the graph, how would you set this one up? Just looking at the graph and what you know of a washer, you know, it's a big circle with a little circle. Can somebody analytically tell me how you would set this up? Anybody?
Finding the area.
Instead of using
Antiderivative with pi out front from 0 to 1 of what?
would it be x cubed?
No. What is the dominant curve of the area?
X.
X. And then what do you do with the dominant? You've got the outside radius. Hold on a second. Let me get a blue pen. Here is the outside radius. What are you going to subtract from the outside radius?
The inside.
Good job. And there's the inside radius. So this is your outside radius. And we're going to subtract the inside radius. And that's going to be x cubed. And that's the inside radius. Now, do y'all see that I made a big deal out of this inside radius and outside radius? Is that important? Oh, hell to the yeah. Because what if I put my axis up here? Then this is the outside radius, and this is the inside radius. So this outside radius and inside radius is very, 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 very important that you understand how to get the outside and inside radius. All right, now it's all calculus and algebra, so finish it. Give you 2 more minutes to finish it. That'd be about 4 minutes for this problem. Well, I can't get it to, there we go. Wonder if you can freeze the screen on this thing. Slow motion.
Priority 1 message coming in on secured channel.
Okay. So that's going to be V is equal to pi times 0 to 1 of x squared minus x to the what? 6th. So that's going to be x cubed over 3 minus x to the 7th over 7, evaluated at 0 and 1, multiplied by pi. Well, what happens to the 0? It gives 0 over 3 minus 0 over 7, which is 0. And then you're going to have 1/3 minus 1/7. Multiplied by pi. And then that's going to give you pi times 21, 21, 3 going there, 7, 7 going there, 3, pi 4, 21. Somebody give me 4 pi over 21 to the 2nd decimal point, please.
I got 0.028.
I'm sorry, say it again. You broke up.
0.028.
0.028.
Yes.
Okay.
Wait,
see,
for
four-
4 pi over 21?
I'm sorry. 4 times 3 is 12. And 12 over 24 would be a half. I believe that's
I
a
think
little bit
it's
too low.
0.59.
0.59.
I got 0.598.
Okay. 598. Somebody verify one of the two.
Yeah, I got the same thing.
0.598.
Yeah,
My
0.5.
bad. I thought you said to second power.
Okay. So 0.598 cubic units.
Yep.
So this is some kind of, if you wanted to draw it, I don't know if I could draw it or not. It's something that looks like this. And it would, looks like, does that look decent?
Next.
I don't know. What does that look like? It looks kind of like a funnel with a cushion in it. I don't know. Funnel with a cushion in it. I don't know. Okay, I can't think of anything that looks like
I
that.
can see a
Rob.
funnel.
Say again.
It just looks like a funnel.
Yeah, funnel with a ridge in it. Oh, I know. Well, kind of like the thing that Veruca Salt and her daddy fell through, the funnel with the kind of, no, that's not it. I don't know. Kind of like that.
No, that was a
Anyway,
good analogy.
that's from, if this was 1 inch, if that was 1 inch, you're talking about 0.6 or half, almost a little over, 0.6 cubic inches. And that would make sense because if you filled it up and it didn't have any, it would be almost 1 cubic inch. But since it's got the padding, since it's got those ridges, that ridge in it, it's going to be less than 1. Anyway, it's always good to try to draw it, to try to picture it, so that makes sense. But that is considered to be extra work and extra thinking, and some of y'all don't want to do that at all. So, but some of y'all might want to draw it and see what it looks like. Okay, let me give you a nerd. This one has several parts. Y is equal to the square root of x. Y is equal to x. And I want to know what the volume is, A, when you're revolving around the x axis, B, when you're revolving around y is equal to -3, and C, when you're revolving around y is equal to 8. And I would suggest that you treat these as 3 different problems. So you're going to draw 3 different graphs, and I would use 3 different pages because you need to draw a big graph of each one of these because it's going to make sense if you draw it big enough. Because I'm going to go to the next page to draw, I'm going to do A on the next page. You can go ahead and get started by graphing it on the next page if you want to. Make sure you draw it big. So I'm going to go to the next page. And I'm going to put the, let's see, y is equal to the square root of x, and y is equal to x, and we're going around the x-axis. So I'm going to take my handy dandy highlighter, and we're going to color this one yellow, and y is equal to the square root of x is basically this. And we'll color this one pink. And that is a 45-degree angle, like that.
Priority 1 message coming in on secure channel.
So, of course, we're looking at this area. You have not met anybody that sucks at coloring more than I suck at coloring. I used to make bad grades on my coloring when I was in elementary school. I sucked at it. I guess the old adage, color outside the lines, is very accurate. Hopefully some of y'all can relate. But you're not going to tell me because you don't communicate with no damn body, so I don't know what that is. Okay, go away. I don't want to reboot. I can't get out of this, so if it reboots and the class is over, I can't get out of it. I don't know what the heck this is. I'm just going to hit OK, and if it goes out, I hope it doesn't. Okay, we know that this is going to be 0 and 1. That's going to be 1 right there. Because when you square both sides, you're going to get x is equal to the square root of x. 0 and 1 is going to be your and we are going around the x-axis, so there is our shell, so you know you've got something over here that looks like that. So you've got, instead of the picture we had, you've got more of a what? Watermelon type look to it. Except it's got let's see. I would say it looks something like this, but it's got these like that all the way around it. Does that make sense? So it kind of looks like a, I don't know, you'd have to, I don't know, it's got some kind of look like that to it. All right. So if you just did around, that would be volume is equal to, we're just going to set these up. We might do one of them. From 0 to 1 of the outer minus the inner radius. Now I'm going to take my 2 pins. My green is going to be my outer radius. And my pink is going to be my inner radius. So what is my outer radius? I'm sorry, I got to draw. I should have drew the washer. Hold on. I don't know if I can do this without messing my picture up. Let's see, this is like that. There we go. There, how's that? Does that look like a washer?
Yeah.
All right, somebody tell me what the outer radius is, or the dominant.
Square root of x.
And what is the inner? All right, I want everybody to do the next line. Give me the setup and box it in. In other words, I just want you to do the setup on this one. So V is equal to pi 0 to 1 of x minus what?
X squared.
And there's your setup. Now, does everybody see how important the outside and the inside radius is now? If you
Yes.
don't see it, you're going to see it on the next problem. I don't like that green. I'm going to use this purple. I know it won't show up, but that's purple. Okay. Now do the next part. B says revolve. Let's go ahead and write everything down. Y is equal to the square root of x. Y is equal to x. But now we're revolving around y is equal to -3. So the first thing I do is I got to make a new axis. 1, 2, 3. There's my new axis, -3. And I'm going to highlight this one green because that's my new axis. This axis up here, it technically don't exist anymore. We're going to focus on this axis right here. So I'm going to highlight it green. Now we still got our picture, we still got our graph up here. Our graph looks like yellow. Hold on. Y is equal to the square root of x. And y is equal to x. So we still got that going on. Trying not to overlap with the colors. I'm trying to be good coloring boy. There we go. And we still got 0 to 1. But now we've got what? We've got this guy right there. And then we've got, where's my blue? Got this guy right here. So remember, this is our new origin now, which is that -3. So this distance right here is 3. I want you to put that down right here. This distance right here is 3. So somebody tell me, am I adding on to 3 with the blue line and the black line, or am I subtracting from 3? Tell me. What does it look like I'm doing? I'm adding on to 3. Does everybody see that? Because 3 is right here. This up here, that's adding because I've got to add to get to up here. So that's going to be 3 plus these guys. So what's our outside radius? What's our outside radius? The blue. And our inside radius, I'm going to do that in orange. Our inside radius is in orange. And we always subtract. And we have volume pi times antiderivative from 0 to 1. All right, I want somebody to give me the nomenclature for the outside radius of this problem. I already gave you the square, so you just got to give me what goes inside.
Square
That means I want
x
somebody to say
plus 3.
something.
Square root of x plus 3.
3 plus the square root of x. Now, even though addition is commutative, why am I making an emphasis on the 3 plus the square root of x? Why am I saying it like that? Because where am I? I'm right here, right? That's my axis, right? How do I get to that yellow line? How do you get to the yellow line from this blue dot? You got to go 3 miles, plus you got to go with your directions. So that's why I said 3 plus the square root of x. Somebody tell me the inside radius.
3 plus x.
3 plus x. And that is dx, and that's the setup. We're probably going to come back and do this one, or we'll do the last one as far as the algebra goes. I mean, as far as the calculus. All right, I'm going to leave that on there. That's B. Now, is C going to be exactly like this one? No, it's not going to be exactly like it. It's going to be a little bit different. So let's go to C. C says y is equal to the square root of x. Y is equal to x. And this time we're going to revolve around y is equal to 8. Okay, draw it.
As in now, a minute.
Say again.
Yep. I forgot my mic was still on. Now I'm kind of exaggerating the width because I'm trying to show you, I'm trying to blow this up, and that's why it should be like right in here, but that's too small. So I'm exaggerating the length, okay? So just, okay, does everybody agree with this is the drawing, except for me exaggerating a little bit? Yeah. That looks
Okay,
right.
somebody tell me what that distance is right there.
8.
The blue distance.
Eight.
Everybody with me? Okay, now I'm going to take my, we'll get 2 colors. Let me get a, let's go with this pale looking green. I'm going to do my outside radius. And I'm going to do a pale looking, well, I haven't used orange yet, so I'm going to use orange. And there's my inside radius. Because remember, I'm not drawing a big washer because it'd take up too much of the picture.
But we're revolving around this guy. So I'm just going to draw the inside of the washer. There's the inside. And then the outside would be so let's go with 0 pi volume equals 0 to 1, and my outside radius squared minus my inside radius squared dx. Is this problem the same as B? No. Somebody tell me why this problem is not the same as B.
Yeah.
Because your new axis is what?
8.
And it's what in relation to the problem?
It's above it.
It's above, right? Where was B?
It was
Below.
below it.
It was below. So below, we what? We add. Because the distance is below the problem. So we add to get to the problem. We have to walk 3 miles, and then we have to walk our directions to the problem. So somebody tell me, what is this one going to be? Somebody give me the outer diameter, looking at the green line right here. Tell me what the outside diameter is.
8 minus square root of x.
Good job. 8 minus the square root of x. So go ahead and write that down. I mean 8 minus x, sorry. Remember, the pink is x. So that's going to be 8. I'm going to put 8 in blue. Minus and x in pink, because that's the x. And somebody tell me what the inside radius is. 8. Oops. 8 minus what?
Square root of x.
Square root x. What do y'all see as I'm showing you these couple of 2 problems? What does everything revolve around? I mean, no pun intended. What does everything, if you didn't have this one thing, you couldn't do the problem. And what is this one thing?
Where your axis is.
Well, your new axis is.
But what is this called? Your drawing, your sketch.
Your graph.
Exactly. What do we call it in physics? Free body what?
Free body diagram.
Diagram. Are you getting in the habit of doing that? Yes. Will you be doing that in Calc 2? Yes. And I don't care how smart you think you are, you're going to be drawing some free body diagrams in Calc 2 and physics. You will be doing that. Now, let's finish the class with finishing this problem as far as the calculus and the integration. So you got shortcut number 2, shortcut number 2. So you're going to do shortcut number 2 twice. A minus B, quantity squared.
A minus B quantity squared. You got to hurry because we only got 7 minutes before some of y'all self-combust. I'm going to write this on the next page. And I'll tell y'all a little secret. I could never understand the difference. When I was in calculus, I could never understand the difference between B and C until I had a graduate student at Clemson, and the graduate student showed me the same thing that I just did with y'all. And that graduate student fixed it. So that's the difference between B and C, is your axis is above and below. This is C. So pi 0 to 1, 8 minus x quantity squared minus 8 minus the square root of x quantity squared dx equal to pi 0 to 1, 64 minus 16x plus x squared minus 64 minus 16 square root of x plus x. And I need everybody to check me, make sure I didn't screw up the shortcuts. Well, at least the 64 is canceled. If I did everything right. And we've got pi antiderivative from 0 to 1 of x squared minus 17x plus 16x to the 1/2. And I'm going to give everybody a chance to check me and make sure I didn't mess up anything. Give you 30 seconds to check everything. And that's going to be x cubed over 3 minus 17x squared over 2 plus 16x to the 3/2 over 3/2. Evaluated at 0 and 1 multiplied by pi. X cubed over 3 minus 17x squared over 2. 2/3 is going to be 2, that'd be 32 over 3. Somebody check my math, please. And we all know what happens to the 0. So we've got 1/3 minus 17 over 2 plus 32 over 3. Y'all check my math. Times pi
6, 6, 6. Two, 3 times 17 is what, 51? I need somebody to check me. 3 times 17, what is it? Three
Yeah,
times
you were
17.
correct.
What?
You was right.
51?
Yeah, it's 51.
Okay. And 2 minus 51 is negative what? 49. So that's going to be negative 49 plus 64 over 6. So if I had negative 50, that would be 14. No. Yeah. So it's not 14, it's 15. Somebody check me. Is it 15 over 6?
It is 15 over 6. Would you not simplify that to 5 over 2?
Oh yeah. I don't listen, I ain't got enough room to do that. Yeah, you would simplify it. I don't care. Decimal, fraction, I don't care. Main thing is you understand how you got there. All right, now you know. Now you've got 2 or 3, you got 4 problems because that was technically 3 problems we just did. We did A, B, and C. Where's A? Here's A. There's A. Okay. So what did we just do? Well, we just did the last 2 days, and I'm just going over this for people that haven't done their homework yet. Yeah, I know, I'm a bastard. I'm going to keep doing it. We have gone over 6.2, and, well, we're going over 6.2, 6.3, and 6.4. And this is the area between curves, I think. And this is disc and washer, I think. They may have put washer and ring or shell down here, but I think the way I'm doing it, I've just taught you this yesterday and this today. Tomorrow will be shell. It's what I like to call ring, but that's
Monday.
tomorrow. What?
I just said Monday. We
Yeah.
don't have questions.
Yeah. Okay, so that's probably Monday. All righty. Now, I don't have to take the roll because they locked me out of attendance tracker on Thursday. So everybody have a good weekend. What is today? Thursday? Yeah. Everybody have a good weekend and try to get up to 6.3 homework. Okay, and we're not talking about a lot of problems. How many problems? Those 5 people that did the homework. How many problems? 10 on each one, maybe?
It's like 9, something like
Huh?
that. It's like
It's like
9.
it varies. Some of them's like 6, some of it's like 10.
It's less
Yeah.
than 10.
Less than 10. Yeah, 9 or 10. So it's not that big a deal. For those 5 people that have done it, you know, y'all are doing good. The rest of y'all suck. All right. Y'all have a good weekend and get that homework done. See you later.
You too.
See ya.